Hi, it's Jason Gorman here from Codemanship with the first in a series of videos on test-driven development for Python programmers. You may have heard of test-driven development. If you're watching this video, you probably have. You may even have tried it. What we're going to be doing over this series of videos is we're going to be demonstrating some of the key practices of TDD in Python, and hopefully you'll get a real feel for practically how it works. Starting with the most basic practices of all, which are the 3 steps of the test-driven development cycle. Now, as the name implies, test-driven development means driving the design and development of our code using tests as specifications. And it's what we call a microcycle or a micro iteration with 3 steps. The first step is that we start by writing a test that fails. So we write a failing test, and that describes something that we want the software to do that it currently doesn't. So it's a specification, a test acting as a specification for something we want the software to do that it currently doesn't. And then we write the simplest code we can think of, the quickest thing that comes into our head, that will make the test pass. And it's important to get the test passing quickly, because when our tests are passing, then we have the luxury of being able to sit back knowing that our code is working, and we can think more about the design and about where we want to go next. So we write a failing test, then we write the simplest code to pass the test, and then very, very importantly, before we move on to the next test case, the next part of our design, we stop and we take a look at the code. We have a little mini code review with the code that we've written. And if there's anything that we think should be refactored, that is improved, to make the code easier to understand or to make it simpler or to remove duplication, or more generally to make the code easier to change going forward, then we would stop and we would refactor the code before we move on to the next test case. So we start by writing a failing test. We write the simplest code to pass the test, and then if necessary, we refactor the code to make it easier to change going forward. And that's very, very important, that third step, because that's often where a lot of design decisions happen. Okay, so we're going to demonstrate this process using a very simple business example, which is an online shopping basket. So we have a shopping basket with items that have a price, a unit price, and a quantity. And our requirement is we need to be able to total the items in the basket. Now, in TDD, we tend to find that it's a good idea to start with the simplest example, the simplest test case we can think of. And the simplest case I can think of for a shopping basket is an empty basket. What would be the total of an empty basket? Now, to demonstrate this in Python, I need a unit testing framework, and just so happens that Python ships with its own unit testing framework. It's formally known as PyUnit, but often people refer to it as UnitTest because that's the name of the module that we need to import. So we don't need to use pip to import any packages here. We can just use it straight out of the back. So let's start in our test file here by importing UnitTest. Okay, so that comes with Python, it's already there. Okay, now a test fixture, which is just a class that contains test methods. A test fixture with PyUnit, with UnitTest, is just a class that inherits from a class in UnitTest called test case. So let's call this class, I don't know, shopping basket test. That would make sense. It's important that your test fixtures are named so that it's obvious what they're the tests for. And all we need to do is inherit from test case, like that. And that is now a test fixture in UnitTest. So the tool, when we run our test, the tool will know to look inside this class because it inherits from test case. Test methods are methods that begin with the word test and underscore. And our first case is just an empty basket. So what's the empty basket total? So again, I'm naming my test so it's obvious what this test is. That should be def. Okay. And basically when we run our test fixture, the tool will know to look for methods that begin with test underscore. And these methods, their signature is very clear. They don't take any parameters. They just have a name that begins with test. And of course, they don't need to return any data either. Okay, now we need to set up for our test. Now, here's where a lot of people struggle with TDD. The idea is, and the clue is in the name, the test is what drives the design of our code. So a lot of people will say, well, how can I write a test for a shopping basket if there's no such thing as a shopping basket in my code? We need to do it the right way round here. So what we actually do is we make a design decision here. We imagine that there is such a class as a basket, for example. Let's imagine that it takes the items in the constructor there. So an empty list of items. And you'll see the red squiggly line. So PyCharm is complaining that this class doesn't exist. Now, this is the golden rule of test-driven development. We don't declare source code unless we have test that requires it. So at the moment, we have a broken test here. And in order to move on, we need to fix this by declaring this class basket. Notice the tool is designed with working backwards in mind. So it kind of knows that I want to do that. So we're working backwards from the test to the design of the implementation. Okay, and I think probably the easiest way to set up this class, you might not be familiar with these yet, they're relatively new to Python, is we can declare it as a data class. So a data class in Python is used for classes that are primarily used to just store data. They're mostly just fields. Our class is going to have a little bit of behavior. It's going to have a total method, but really it's just a list of items. So the simplest way to declare it would be as a data class, and you will see that we just need to import that from the data class package, which again is part of Python 3 onwards, I think. And data class is all we need to do to declare that it has a list of items is declare a field like this. And I'll declare that as a list, which is an internal type. So let's import this from typing. And what will happen when it at runtime is it will generate a constructor for its fields. So this constructor here for basket basically is going to work because it's actually going to generate a constructor. Okay, now we can use that to test what the total is. So we're going to use the assert equal method of our test case class, and the first parameter of that is the actual value, which in this case is total of the basket. Notice that I didn't declare a total method and then use it. I used the total method in the test, and that means I have to declare it. So that's what test-driven means, and its total should be 0. Okay. So let's work backwards from there. We need this total method. And for now, we don't need to return anything. Okay. So there is our failing test. Let's just check and see why it's failing. Okay, yeah, so it's expecting 0, but we're not returning anything at the moment. So that's our failing test. And what we do next is we do the simplest thing we can think of to pass this test. Now, again, another thing that confuses people about test-driven development is at this point, some developers would write some code to calculate the total of items. We don't need to do that just to pass this test. All we need to do to pass this test is return the right answer. So we can just return 0. And there we go. We have a passing test. It's as simple as that. So we wrote a failing test, and that described what we wanted the basket to do when it's empty. What's the total when it's empty? Then we did the simplest thing we could think of to get it passing. We get it passing quickly. Okay, and now we can sit back and take a look at the code that we've written and go, are we happy with this code before we move on? Or do we need to refactor? Well, I think so far, so good. But there is one thing that's bugging me, and that is this is source code now. This is the solution code, and I don't think this really belongs here. So we're going to move this into the root folder here and just call it shopping basket. Okay. There we go. And as soon as I've done that refactoring, I'm going to rerun my tests and make sure that it's all working. Okay. So there's our new shopping basket in its own little file there. And there's our single test. So we wrote a failing test. We did the simplest thing we could think of to pass the test. And now, after we've refactored, we can move on to another failing test, another example that our design at the moment can't handle. So let's try with a single item. And the quantity is 1. So just one unit of a single item. Okay, so what we're doing here is we're working in these little micro iterations of design and feedback, and we're making a small number of design decisions, and then we're getting it to work, and then we're stopping and looking at the code. So these little feedback loops are very, very useful for bringing a lot more focus to the design decisions that we're making, because we're making fewer decisions with each loop. And the whole time we're making sure that our code is still working. When we bring more focus to each design decision, what we tend to find is that the designs end up better than if we made a whole bunch of decisions, if we wrote like 100 lines of source code and then tested it. So one of the advantages of test-driven development is working in these short, very small feedback loops, where the number of design decisions that we need to sort of consider in each loop is relatively pretty small. So we bring a lot more focus to design. Okay, so again, there's our setup. We now have a basket class, but this time it's not empty. So what we're going to do is we're going to pass in a collection of one item, and let's give it a unit price of 100 and a quantity of 1. Okay, and again, golden rule, item doesn't exist, which gives us permission now to fix this test so we can move on to declare that class. So let's declare that class. And okay, and again, the simplest way to set this up would be as a data class. And in our data class, we've got 2 fields basically. The first field is the unit price, and that's a float. And then we need to know the quantity. How many items of that do we need? How many units, sorry. So we now have our test. Not just about, we need to make an assertion. So let's assert this time that the basket total will be equal to 100. Okay, and that test is failing. Lovely. Right. So let's go to our implementation here. What do we need to do to make both of these tests pass? Well, first thing that pops into my head is say, look, if the basket's not empty, then what we'll do, well, I keep thinking I'm working in JavaScript. You don't need those. We need to make sure we're referencing the field. Okay, so if the basket's not empty, then we'll return the price of the first item. Okay, hopefully that will work. Nope, lots of assertions failing. Unit prices is why. This is why we pair program, and this is why we need tests. Okay, so that's passing. There's a little bit of cleanup I want to do here. We can make this a bit more strongly typed. So let's make that a list of item, and we can import that. Let's rerun our test. Not at all keen on that. What have I done here? I think I know what I've done. Yep. Okay, can't undo it. Right, okay. I know what I've done there. I've created basically a loop. So let's not have a loop. That should be working. Thank you. Okay, now what I need to do then to make this work is I need to move this into its own file in the root folder. So let's call it item. That would make sense, wouldn't it? Okay, and now hopefully we can make this a list of item, and that should still work. Lovely. Okay. So now item and shopping basket are in their own files. Our test code is looking pretty clean. Very important, and we'll talk about this in future videos, to consider refactoring your test code as well, because test code is code, and if your test code is difficult to understand or difficult to change, then you've got a problem. So don't forget to consider your test code when you're thinking about refactoring. Okay, what's the next test case I can think of? Well, what if there's two items um, with quantity 1? Okay, so this time there are, oops, two items. Let's give them simple price, so they're both the same. And the total for this should be 200. So our design really taking shape now. We've made some good decisions, I hope. Now let's run that and see what happens. Okay, so our assertion is failing. Good. Let's see why it's failing. We'll discuss this in a future video. Okay, now what can we do that would be very simple, that would work for all of these three cases? Well, I think we can do a little bit of functional programming. Let's use a reduce. So I'm going to use a lambda here to accumulate essentially the unit prices. So there's our item of each item. So our accumulator is just the subtotal plus the item unit price. Nice and easy. Okay, and that's for our items list. Because we can have an empty list, we need to specify also a starting value for our subtotal there. Okay, and hopefully when I run this, that will work for, oh, nope, it didn't. Interesting. Self item 0. Return, Jason, you need to return it. See, we all make mistakes. Lovely. Okay, so now we're getting somewhere. Now there's a little bit of logic here that's really starting to emerge. And I can think of one more test case maybe that we should try to finish this off. Let's just review our code first. Are we happy with the code the way it is? I think so. So we can move on to a final test case maybe. So we got, it's a single item, but this time the quantity is more than 1. So let's make it 2, for example. Oops. So again, we have our basket. We've got a single item in our collection there, and the price is 100. But this time the quantity is 2. So we're expecting our basket total to be equal to 200. This should fail. Oops. Accidentally pressed undo instead of save there. So let's see if that fails. Okay, another failing test. Yep. Now, in our shopping basket, all we need to do at this point is one small change. Quantity. Okay, and there we go. One last code review. I think things are looking kind of okay. Let's just do a little bit of code formatting. So, and in our test code as well. Okay, well, our test code is already correctly formatted. So that is test-driven development. That's the basic cycle. We flesh out a design one test case at a time, and for each test case, for each example, starting usually with the simplest example, we start by writing a test that fails. Then we write the simplest code we can think of to get that test passing, and of course, all the other tests that come before it should still be passing. And then we, if necessary, we review our code, and if necessary, we refactor the code to make it easy to change, easier to work with going forward. And that includes the test code. And what we do as we add each new test case, as our tests get more and more specific, our design, as you will notice, gets more and more general. So we end up coming up with a general design that works for all of the test cases. This is a process that Kent Beck in his book, Test-Driven by Development by Example, calls triangulating. I'll put a link to the book below, as well as a link to the documentation for PyUnit. So that's our first video. That's TDD. Those are the basics. And what we tend to find is, once you've got the hang of those basics, there's a bunch of other stuff you need to think about, relating to design, relating to what are good tests and what are not so good tests, relating to how we deal with external dependencies, relating to how we approach the design process, whether it's working from the inside out, where we test drive each part of the jigsaw and then put the jigsaw together at the end in one high-level test, or whether we work outside in. We start at the high level and then we kind of discover the pieces of the jigsaw as we go. So there's a lot more to think about, a lot more to see. So in future videos, we'll be going through some more advanced topics. I hope this has been of some use. Remember, in the description below, I'll put a link into Kent Beck's excellent book, and I'll also put a link to the documentation for UnitTest. And I will see you on the next video.